Sonomatic are an inspection services company. We work mainly in the power generation, oil and gas and nuclear sectors. We've got about 200 employees worldwide with offices in the UK, US, South Africa, Middle East and Australia. We provide conventional and specialised non-destructive testing services to our clients to provide them assurance on the integrity of their assets. We dealt with the ultrasonic sensing equipment on the crawler. We also dealt with the electronics that connects to the ultrasonic equipment and the data collection. So the sensor uses ultrasound in order to detect the thickness of the plate below the array. Any changes in the thickness can then be recorded and correlated with the location in order to identify areas of concern. We looked at what kind of frequency probe we should use. We also decided to go for an array with 128 elements. Normally you would use 1 or 2 or maybe 8 elements. We've used a much larger array, which allows us to collect a lot more data more quickly. We also designed some custom electronics in order to power the array and to collect the data. Because the electronics are mounted on the back of the array, this allows for much quicker data transmission, which allows for overall a much quicker scan. As I've said, we have offices around the world, so it was similar to working with some of our other offices. It's been slightly different in that we're working with partners that we haven't worked with before, and it's just been a matter of sticking to the schedules that we've set out and flagging up any concern. And just good communication between all parties makes the project go quite smoothly.
We are involved in developing the localization and navigation system for our Nautilus project. Previously, we had some work with different partners in a different project, which has been successful so far. And in this time, we work with Sonomatic, which is give us insight, the work technology also to be successful in this project. The big challenge was to localize the robot inside the tank, which is because we got like 3 set of beacon outside the tank, and the main penger is in the submerged in the oil. So also the good part of this project was because of this collaboration, we got many expertise from NDT to robotics and the control, which is help us to build up effectiveness of this project. The localization system, which is we have developed, is like a new system because we're using a radio wave to transmit the position of the robot submerged in oil to outside world. So we use a triangulation to get the coordinate of the robot inside the tank. So, and also we use this sonar, which is we developed to navigate the robot around for obstacle avoidance, because inside the tank is not free to move. You got some obstacle like tank roof and tank roof support, and also some pipe around the tank. It is important to get the absolute position of the robot because for corrosion mapping, and also if, for example, you find some defects during the inspection, the tank owner can go back with those coordinates and repair or for further monitoring of the tank. Send the robot back to that position and also inspect. For example, in terms of monitoring, you can send back the robot to see the state of the tank, if the corrosion is further or not. In that case, you can empty the tank and repair it or keep monitoring of the robot by sending it back.
Innotech is a dynamic and progressive research and innovation company based in Cambridge. We are specialized in designing and commercialization of novel robotic solutions to overcome the industrial challenges, especially in the industry like oil and gas, renewable energy, offshore, air, aerospace, and rail. Our extensive expertise includes providing consultancy service and collaborate with industries to address the real-world engineering problems. The design criteria of the Nautilus was quite challenging, especially because of the challenging environment it's being deployed. Example, deploying the crawler in the oil tank, which is completely submerged without draining the oil out of the tank. So we need to design the crawler, particularly this crawler, to be safe to be operated in a hazardous environment, and we also need to satisfy the ATEX design guidelines. So the ATEX, it's atmosphere explosive. It certifies that this particular product is safe to operate in potentially explosive atmosphere. And other design criteria, the very tough design criteria was ability to drive on the thick slippery sludge surface, and there may be some internals in the tank which the crawler need to overcome. At the design stage of this project, we have all the partners thoroughly discussed about the integration of each system and agreed with the interfaces. We have quite few setbacks in the beginning of the project regarding what's a suitable method of protection, because different approach was there, like it can be encapsulated or pressurized. So finally we have selected a pressurized method of protections, and other few setbacks were regarding the position and mounting arrangements of sonar and non-destructive testing systems. Driving on this slippery sludgy surface is quite challenging. Yes, indeed, we need to do lots of testing. So first the tracks were individually tested to determine its coefficient of friction to check whether it slips in the oil. And other testing was we pressurized once the crawler is completely assembled. After the electrical and software integration, the crawler was pressurized and checked for any leaks. So first we conducted a dry pressure testing followed by underwater testing for certain number of hours. The pressure drop inside we have some pressure sensor mounted inside the crawler, so the pressure reading were continuously monitored to check for if there is any potential leak at the time of testing. So basically the crawler is tethered crawler, so always it's been connected with the umbilical cable. The umbilical cable established the communication between the controller and the crawler, and there is a fiber optic Ethernet switch mounted inside the crawler, and the controller will communicate via the fiber optic cable mounted inside the umbilical cable. So we are sending instructions to the crawler via UDP and TCP protocols. Similarly, the data collected from the NDT and the sonar will be transmitted to the control box, and the NDT data obtained at the time of inspection are furtherly processed and mapped with the corresponding location data obtained from the radio frequency signals. The unique features of the Nautilus is that the whole body of the Nautilus is a stainless steel, including the tracks, sonar, and the NDT holders, so it's a corrosion resistant body. And the next thing is that it has a semi-autonomous drive, so once if the operator specifies to which location he goes, the crawler goes by itself and stops at the endpoint. And we also have a active drive control, so even though if the crawler loses its traction, instead of going in a straight line, if it tilts to right or left, it can autocorrect itself and can drive straightly. And other features are its ATEX rated crawler, and the important feature is the size of the crawler. The size of the crawler is compact, so it can be easily deployed via a minimum manhole size of 450 mm.
We have formal meetings every quarter, which we'll look at what we've planned and forecast of the work plans that we've got ready. We look at all then the finances that we've spent in that quarter, and then we present that every quarter to the PMO, which is the project officer, on looking at the claims. What we have is an overall Gantt chart with each individual work plan, who's involved, and then we have each individual member has a certain responsibility for each module to be delivered. So for instance, we are in charge of commercialization, IP, and we did a bit on the QFD at the front end, so we're responsible for that. Not that we solely do that, we involve all the others, but that's how each one has an active role in coordinating each individual. And then we control it, as I said, with the quarterly reports and the financials. When you look at what is currently out there are a number of submersible robots that can be applied or deployed to the tanks. But quite often what we've seen and what the market's seen is the size, the physical size of of the existing robots are probably 2 meters in length, weigh up to 1/4 of a ton. So you can imagine the deployment side of it, the number of people they need to deploy it, the size, the access is then limited to where they can go. So what we've done with the Project Nautilus, we did a very extensive upfront piece of work, which is technical term is a QFD, quality functional design specification, where we went out to over 100 current users and tank farm operators of what their must-haves, nice-to-haves, and what it would look like. And it came back where we were looking at, the ergonomics of it, the ease of use, the size, the deployment, the limiting factor of the number of people that need to deploy. Because if you see these in the real world and you look at what is required, don't forget you are actually potentially working in an explosive environment. The need for it is one of size over the existing ones. The technology, which is localization, a lot of what LSBU have been involved in is incorporating the localization where the robot is. And I mean, it doesn't sound a lot, but within 1/2 meter we can tell where the robot is at any one time in the tank. That allows us to actually be very detailed on where it is, where the faults are, so that going forward the concept is we could be able to redeploy the robot by exception, rather than just doing the whole tank, which might be a couple of days or 3 or 4 days of tracking. We can go down, they can deploy it, just go down, check the areas to see is how much worse it's getting. The normal tanks and deployment, they're deployed through the top of the tank with a big hatch, and that is the problem area, because what you're doing is, and that's where the explosive is, where you're passing through the vapor layer. So that, and again, you have to have a big A-frame on there. If you think you have a lifting device to get something that's potentially 1/4 of a ton up onto the top of a tank. Now, with the miniaturization, it's basically, layman's terms, it's an 18-inch square, whatever the metric is in that. So 18-inch square. So that means we could actually have access portals on the side. So we could actually, if you think like a diver's bell type scenario, where we could potentially put that on the side of a tank, bolt it up, open the other side, and then away we go. So it makes big advantages in deployment. Originally, the two main applications that we designed the system for was existing tank farms. If you look at tank farms, oil storage tank farms, those are global. So we are already talking to people in America, Singapore, Australia, South Africa, the Netherlands, the UK. So it is a global. There's roughly about 600 sites across the world where we do oil storage. But other than that, there's then your floating storage, which is your tankers. So again, we can go on to the tankers. Predominantly it's been done for in oil or in fuel scenarios, but there's no reason why we can't pass this on to other sides of tanks. And again, the main point about this is it's done while the tanks are full of fuel. There's a very big interest. We've like I say, we've been the 600 tank farm operators, and we've got an active response already from about 70 tank farm operators on the use of it, and we've had a number of offers to utilise the Nautilus system on their tank. I think in the oil industry there is an overarching goal that they're going to make it manless by 2030. Part of the commercialisation that we are looking after. So we're trying to generate interest, we'll say, in the collective of the robot. But what we've already seen is it may be that, okay, they have an existing system, but we can then deploy the sensor, so we can license the sensor in. The localization that I was speaking about earlier, that LSBU have created, there's no reason why that can't be, as a separate entity, deployed onto SEP. So what we're looking at with our vision of is, yes, you've got the robot in its entirety and what it can do, but then you've got the individual technologies that on them that we can strip out individually and license to possibly existing and other applications.